Okay, in continuing with what we have for quadratic equations and equations of other types, we have just resuming what we had in the Alex handouts. From this equation, we have the square of w plus 9 minus 8 is equal to 0, and we are looking at solving for w. And again, we were looking at squaring out w plus 9, and in the context multiplication, we have w plus 9 times itself minus 8 is equal to 0. And looking at foiling out what we have in the square of w plus 9, so we have w times w is w to the second, and we have plus 9w, outside product, plus another 9w, the inside product, and the combination of the outside and inside products will be at 18w, and we have 9 times 9 is 81, and then we have minus 8 is equal to 0, and as we get nearer to the quadratic equation in standard form, so we have w squared plus 18w plus 73 is equal to 0. And here we have a trinomial that we cannot factor into integer coefficients. Okay, so we can utilize the quadratic formula. So we have a at 1, b at 18, and c at 73. And now, while we are not using the letter x, we can still apply the quadratic, okay, for the variable w. Okay, so we have for negative b, so we have negative 18, and we have plus or minus the square root of b squared minus 4ac, so we have the square of 18, and we have minus 4 times 1 times 73, and we have all over 2 times 1, and as we get closer to solving for w, okay, and we're going to have a couple of irrational roots, it looks like. So we have for w, okay, we have negative 18, and we have plus or minus, and we have the square root of 324 minus 292, and we have all over 2, and taking what we have now, okay, so we have in the radical, now 324 minus 292, that's going to go to 32. Now for the square root of 32, okay, the highest perfect square that will be divisible into 32 is going to be at 16, and we have the square root of 16 times the square root of 2, and that we have in 4 times, okay, the square root of 2, and we have for filling in, so we got w is equal to negative 18 plus or minus, and we have 4 times, okay, the square root of 2 all over 2. And for what we have in this set of expressions, okay, now if you notice we have even leading coefficients. So if I factor out 2 from the numerator, we have 2 times the quantity of negative 9 plus or minus 2 times, okay, the square root of 2 all over 2, and we have the factors 2 to cancel out, and we have with the reduction. So we're going to have for w, we have negative 9 plus or minus 2 times the square root of 2, and you can write this in separate form. So we have at the lower end, we have negative 9 minus 2 times the square root of 2, and we also have negative 9 plus 2 times, okay, the square root of 2. So we have v plus 1 over v minus 1, followed by the additional 1 is equal to v minus 6 over v minus 4. And for v, we have the excluded values of 1 and 4, since v minus 1 and v minus 4 cannot be equal to 0. And now what we're going to do here is that we're going to clear out the fractions utilizing the least common denominator. So we have for the LCD, we have v minus 1 times v minus 4, and if I take what I have here and distribute the terms over this equation, and we have and just duplicating what I have here, So we have, in terms of spreading out, what we have in this particular case. All right, so we got in this one. Okay, so multiplying by, okay, the least common denominator. So we have v minus 1 quantity times the quantity of v minus 4. And we have times the quantity of v plus 1 over v minus 1. And we have, again, distributing, so we have v minus 1 quantity times the quantity of v minus 4 times 1. That part gets a little rhetorical. And we have to the right. Okay, now we're going to eliminate v minus 4. And so we're going to have, in this particular setup, all right, so you have all the denominators are going to be canceled out. So v minus 1s will go out. V minus 4 is going to go out. And looking at what we have left over, so we have v minus 4 quantity times the quantity of v plus 1. And looking at what we have in distributing, we also have v minus 1 times the quantity of v minus 4. And we have over to the right, okay, we have, again, the v minus 4 is going to cancel out. And we have v minus 1 quantity times the quantity of v minus 6. So we have 3 modes of foiling out. So we have, at this juncture, okay, you have with the first combination, we have v squared. Then you got plus v minus 4v. So we have a negative 3v. We have minus 4. Then we have plus v times v is v squared. Negative 4v minus v, we have negative 5v. And we have plus 4. And we have is equal to v squared minus 6v minus v is negative 7v. And we have plus 6. And as we look at combining the variable terms, so we have 2v squared minus 8v. And we have negative 4 plus 4. That's going to go out. And we have is equal to v squared minus 7v plus 6. And looking at joining together like terms, so we can move everything from the right hand side of the equation over, so I can take out v squared. Likewise, take out negative 7v by adding 7v to both sides. And we have with 6, and take this out. And so we're going to have in the rewrite, we're going to have v squared minus v minus 6 is equal to 0. And we have a trinomial that can be factored. And we have, in this one case, so we have v plus 2. Quantity times quantity v minus 3 is equal to 0. And utilizing the zero product property, so I have v plus 2 is equal to 0. And v minus 3 is equal to 0. And we have with our apparent solutions, we have v at negative 2 and v at 3. And so taking what we have here, these values satisfy the restriction that v cannot be 1 or 4. And so these values will be our 2 solutions in v. Again, so we have v is equal to negative 2 and positive 3. And now looking at solving for x. Now whatever we have for x, it cannot be such that x plus 7 or x plus 2 is equal to 0. So we have 2 exclusions, and those will be negative 7 and negative 2. And if we look at taking what we have in this proportion, so if I take proportional cross products, so we have in the setup, as we map together, so we have 2x, and we have times the quantity of x plus 2, and we have is equal to x times the quantity of x plus 7, and we have with the distribution, so we have 2x squared plus 4x, and we have equal to x squared plus 7x. And looking at combining like terms together, and I can just move the terms from the right hand side of the equation and subtract on both ends. So we have for 2x squared minus x squared, we have x squared minus 3x, and we have is equal to 0. And looking at what we have for x, if I factor out what I have, we end up with the monomial x and the binomial x minus 3. And we have the product equal to 0. And we have with our apparent solutions, we have x equal to 0. And from x minus 3 equal to 0, we have that x is equal to 3. And since we had the restriction that x cannot be negative 7 or negative 2, okay, these answers are legit. So we have x at 0 and also at 3. Now, in the crossover, part of what we had in the handout set was looking at expressing equations in terms of a specified variable. And let's say that for these cases, if I'm looking at solving an equation in terms of a specified variable, we have PV is equal to nRT, and I'm looking at solving for n. Alright, so I want to express the equation in terms of n equals. So I'm going to undo the multiplication by both r and t. And if you notice, okay, we have on the right hand side, okay, both r and t are going to be eliminated. So we have PV over RT is equal to N. And so we're going to have, in terms of N, we have P times V over R times T. All right, now for what we're going to have in the next item, let's say we have an equation whereupon we have that T is equal to K times the square of V. And I'm looking at solving for V. So we have, in this one, we have T is equal to K times V squared. Now looking at trying to solve for V, right now I can take care of the coefficient K, so I can undo the multiplication by applying division by K at both ends. And so we have T over K is equal to V squared, or in commutative terms we have V squared is equal to T over K. And just thinking of the square root property of equality, just as x squared equals P goes to x is equal to plus or minus the square root of P. Okay, we have in this one, we have V is equal to plus or minus the square root of T over K. All right, and now in this one, okay, so we have for the next one a little bit more application here. Now we have kind of like a little variation of the compound interest formula, where we have in annual terms for like you had the frequency of compounding annually. So we have for this formula, if I express in terms of the variable r, so we have a bit of a task to undergo, and I can free up the r expression first of all if I distribute p. So you have p plus p times r over n. And I'm still looking at solving for r, and if I isolate the term that consists of r, I can take away the p that is at the front, and we have for the rewrite, I have a minus p is equal to p times r over n. And what I can do here is that with a minus p is equal to p times r over n, I can take with a minus p, I can multiply by n and divide by p. And so for what we have here, so you got PR over n again times n over p. So again, dividing by a fraction is going to be the same as multiplying by its reciprocal. And guess what? N and p cancel out on the right hand side. So we have this in terms of r. And so, and just keeping what we have from the left hand side of the equation and reversing the order, so I can say that r is equal to a minus p times n all over p. And that is one way that you can express the final result in this one. And we're going to continue later on with radicals and absolute value equations.